A proton carrying 1 MeV kinetic energy is moving in a circular path. Suppose this is a proton, right? Of radius r, capital R, okay? In uniform magnetic field. In a uniform magnetic field. Okay? What should be the energy of the alpha particle to describe a circle of the same radius? Okay? Another particle of the same radius. This particle is alpha particle. Okay? Having the same radius r. Okay? So, a proton carrying an energy of EP, suppose 1 mega electron volt kinetic energy. And then, what should be the energy of the alpha particle E alpha question mark? Okay? To describe a circle of the same radius in the same field. Right? Okay. So, this will be the velocity. Okay? Now, these two particles are revolving about the center O. Okay? What makes them to revolve around the center O in a circle? What forces are there? We have one is magnetic field, right? And the other one? Magnetic field will produce what force on the charge? What force? Huh? What force it will produce on the charge? Lorentz force. Okay? Lorentz force. Okay? What is Lorentz force? Formula? Q and then V cross B. Right? And another force? What is the other force? Just like a ball, okay, tied to a thread, okay, the ball will revolve around in a circle. I discussed earlier, right? It means there is a force going towards the center. What do we call that force? Centripetal force, right? There is a force pushing the ball towards the center and another force going away from the center, right? And here we have one force is the Lorentz force, okay, right, going away from the center, and there is another force, centripetal force. What is the formula? mv square by check. Okay, now see this one, we have FL Q cross B, right? Q cross B, and then check. How much? mv square by r, right? Okay, so now these two forces are equal, right? If they are not equal, the particle will go away, right? So these forces are equal so that these particles will revolve around in a circle, right? So we have here F Lorentz force should be equal to the centripetal force, right? Okay, so now we'll take the modulus. Okay, so if we take the modulus here, will be how much? Q and then V and then B and then sine how much? Sine how much? 90 degree. Why 90 degree? What is theta? Theta is the angle between the velocity of the particle and the magnetic field, right? So this is the velocity, right? What about the magnetic field? Right? This one, this one we have here, this is the velocity, right? So the magnetic field, the direction of the magnetic field and the velocity is 90 degree. I think we have discussed this earlier, a lot of these problems, right? So we have here 90 degree and then what do we get here? 1, right? This is 1. So we have here Lorentz force QVB equals to mv square by r, right? We need to find energy. Okay, so we have discussed this earlier. Energy is half mv square, right? Half mv square. Now we need to put this energy E in this equation, right? So what shall we do? Here this D and V cancel, right? And now here we need to find mv. mv will be how much? 2em, right? Square root, right? This is momentum. Momentum is mass into velocity, right? Okay. Now we have here QB equals to mv is how much? 2me square root divided by r, right? Now we have to find energy E, okay, of the alpha particle. Okay, so now here what do we get here? This is r. R is the radius, right? This r is the radius, r. Therefore r equals how much? 2me root over divided by qb. That fine? Okay. Now for proton, okay, for proton r is equal to r, right? M is equal to how much? Mass of a proton 1, right? Proton 1 each, right? And this is alpha particle. Alpha particle is 2,4 helium, right? Okay, so we have here also r is how much? Same. And now we have here m is how much? Atomic mass 4, right? And now we have here E of proton. E of proton is how much? 1 MeV, right? And then E of alpha particle we have to find out. Okay, so now we have here Q. Q is how much? Charge of a proton is 1e, right? 1 electron, right? And then the charge for alpha particle is how much? How much? 2 electron, right? Okay. So what about magnetic field? Magnetic field will be the same, right? Okay. Substituting in this equation 1, what do we get? R, right? Capital R equals how much? 2m 2. This E is how much? 1, right? We get root over divided by how much? Q is how much? 1. And then B is how much? B is B. Right? Okay. So now equation 1 implies R, right? R equals how much? 2, and then we have here 4, right? So we have here 2 into 4 into E alpha, right? This is E alpha square, okay? Divided by QB. Q is how much? 2 electron, right? Here we have here 1 electron, right? 1 electron into B, right? And here we have 2 electron into B. Okay? So now this is proton, right? Okay, let me put it this way. Let us put RR because same radius, right? So we have here equation 2 and equation 3. Okay? Left hand side equal, we equate the right hand side, right? So we have here from 2 and 3, what do we get? Root 2 by 1e into b, and then equals, this one cancel, right? What do we get here? 4e alpha root over divided by eb, right? Cancel. Okay? So what do we get here? What do we get here? Huh? Cancel?
B cancel.
Okay, B cancels, and then you have to find E alpha, right? What is E alpha here? E alpha root over equals how much? 2 by 4 root over. Is that correct? Cross multiply, right? And then what do we have here? 1 by 2, right? 1 by 2, and then? Okay. And then next, how do we find E alpha?
By removing the root.
Huh?
By removing the root.
How? How do we remove the root? We cannot just remove the root, right? By squaring, right? Squaring both sides. You cannot just eat the root, right? You have to do something. And then what do we get here? E alpha is equal to how much? 1 by 2. How much? Use calculator. How much?
0.5.
Okay, how much? 0.5. What about the unit?
MeV.
Why MeV? Why?
Because energy.
Yeah? Because energy. Energy can be in joules also, right? Then it can also be in electron volt, right? So why MeV? Yeah, because it's given here the energy in MeV. Let's call it mega electron volt. Okay, not just MeV, mega electron. Answer is C, right? Okay.